Morning, everyone. Welcome to Global Academy Institute Technology Foundation. Today, our topic is about light, plane, and curved mirrors. Reflection is the bouncing of light rays as it hits a surface. If the surface is smooth and shiny, like glass, water, or polished metal, the light will reflect at the same angle as it hits the surface. This is called specular or regular reflection. Diffuse or irregular reflection is when light hits an object and reflects in lots of different directions. This happens when the surface is rough. Most of the things we see are because light from a source has reflected off it. Incident ray. The ray of light approaching the mirror represented by an arrow approaching an optical element like mirrors. Reflected ray. The ray of light which leaves the mirror and is represented by an arrow pointing away from the mirror. Normal line. An imaginary line that can be drawn perpendicular to the surface of the mirror at the point of incidence where the ray strikes the mirror. Figure A on the right shows the result of a specular or regular reflection, while Figure B is the result of diffuse or irregular reflection. This is the scientific concept behind what you observe in Activity 2. Mirror left-right reversal. Picture 4 shows a girl combing her hair with her left hand. However, in her image, you will notice that she is combing her hair with her right hand. This effect is known as the mirror left-right reversal. The left side of the object appears as the right side of the image and the right side appears as the left. Reflection on spherical mirrors. A curved mirror is a reflecting surface in which its surface is a section of a sphere. There are two kinds of curved mirrors, the concave and the convex mirrors. A spoon is a kind of a curved mirror with both concave and convex surfaces. Two kinds of spherical mirrors. The concave mirror. It is a curved mirror in which the reflective surface bulges away from the light source. It is called converging mirror because the parallel incident rays converge or meet or intersect at the focal point after reflection. The convex mirror. It is a curved mirror in which the reflective surface bulges towards the light source. It is called diverging mirror because the parallel incident rays diverge after reflection. When extending the reflected rays behind the mirror, the rays converge at the focus behind the mirror. Have you noticed that mirrors rarely tell the truth? Do the next activity to find images formed by curved mirrors. In locating the image formed in curved mirror graphically, three important points are considered as shown in the figure A below. Take note that the distance from the center of curvature, C, to the focal point or focus, F, is the same distance from the focal point or focus to the vertex. Therefore, the distance from C to V is just twice the distance between curvature to F or F to V. For example, if the distance from C to F is 5 cm, then the distance from F to V is also 5 cm. Thus, the distance from C to V is 10 cm. Center of curvature C. The center of the sphere of which the mirror is part, its distance from the mirror is known as the radius. Vertex, the center of the mirror. Focal point or focus. The point between the center of the curvature and vertex, its distance from the mirror is known as the focal length. The four principal ways in curved mirrors. Images formed in a curved mirror can be located and described through ray diagramming. Number 1. P to F ray, 2 F to P ray, 3 C to C ray, and 4 the V ray. Concave mirror or converging mirror. P to F ray. A ray of light parallel to the principal axis is reflected passing through the principal focus. Convex mirror, diverging mirror. P to F ray. A ray of light parallel to the principal axis is reflected as if passing through the principal focus F. Number 2, F to F P ray. A ray of light passing through the focus F is reflected parallel to the principal axis. 2F to P ray. A ray of light directed towards the focus F is reflected parallel to the principal axis. C to C ray. A ray of light passing through the center of curvature C reflects back along its own path. C to C ray. A ray of light directed towards the center of curvature C reflects back along its own path. Number 4, V ray. A ray of light directed to the vertex reflects at equal angle from the principal axis. A ray of light directed to the vertex reflects at equal angle from the principal axis. Imaginary extensions of the reflected ray. An actual reflected ray. The following are ray diagramming steps using the 4 principal rays. In determining the position and the nature of the image of an object formed by concave mirror and convex mirror. Number 1. From the object, draw the first ray P to F ray. From the same point in the object, draw the second F to P ray, third C to C ray, and fourth V rays. Number 2. The intersection of the 4 rays is the image point corresponding to the object point. For example, if we started diagramming from the tip of the arrow-shaped object, the intersection of the reflected rays is also the tip of the arrow-shaped image. Thus, you can determine completely the position and characteristics of the image. 3. For a convex mirror, light rays diverge after reflection and converge from a point that seems to be behind the mirror or virtual focus. But the procedure for locating images is the same as for concave mirror. Thank you for listening.